Hello, this is Mrs. Thompson, and today we will continue to talk about inverse trigonometric functions. Objectives today are understanding the inverse cosecant, inverse secant, and inverse cotangent functions. Also, evaluating composite functions involving inverse trigonometric functions. Inverses of cotangent, secant, and cosecant. To evaluate the inverse cotangent, inverse secant, or inverse cosecant, use the identities below. The first identity, the inverse cotangent of x equals the inverse tangent of 1 over x. Second identity, the inverse secant of x equals the inverse cosine of 1 over x. And lastly, the inverse cosecant of x equals the inverse sine of 1 over x. An example, find the inverse cosecant of 2. Well, based on the identity that the inverse cosecant of x is equal to the inverse sine of 1 over x, this would be equal to the inverse sine of 1 over 2. Of course, pi over 6 is the angle whose sine is 1/2. Therefore, the answer is pi over 6. Finding the exact value of composite functions. Determine the exact value of the cosecant of the inverse cosine of negative square root of 3 over 2. Of course, according to the order of operation, we always start inside our parentheses, where we are asked to find the inverse cosine of negative square root of 3 over 2. 5 pi over 6 is the angle that has a cosine of negative square root of 3 over 2. 5 pi over 6 is one of our common angles on the unit circle, so you should have known that fact. Well, after working that part of the problem, you can see that we are left with now having to find the cosecant of 5 pi over 6. The definition of cosecant is 1 over the sine. So the cosecant of 5 pi over 6 will be equal to 1 over the sine of 5 pi over 6. The sine of 5 pi over 6, you should know, is 1/2. From your facts of common angles on a unit circle, and 1 divided by 1/2 gives a final answer of 2 for this problem. Additional examples are provided in this PowerPoint. Same types of problems, just more examples. You may pause, look at, and study these examples as well.